ChatGPT that pissed me off. So, uh, if you want to watch that stream and me cursing at Pina, you can go right ahead. But, instead, we're going to move on to this Solidity course, which is cursed, and I will never get through. When we left off last time, I could not get hardhat to compile, but if we do hardhat compile, it should compile now. Nothing to compile. Okay, well, that's different than it. What was I doing before? Yarn hardhat compile? Go. I think it's his name. New. What do you mean there's nothing to compile? There's clearly a thing here. Okay, so we are at the point where we are going over what already been doing.
The right direction, etc. Now that we have a good idea of where we're going, let's build it. So, per usual, let's do SPDX license.
See, SPDX license identifier is MIT.
Identifier, MIT. We'll do pragma, solidity. Little caret here, 0.8.7. Even zoom out just a hair. We'll trash that.
And we will follow this exactly. So the thing I was doing, or it was doing in the last time, was I needed to change one of these compilers to be different. I don't remember which one did the trick, that I had to do it a billion times. Caret 0.8.7. Oh, okay, well, is it just never going to believe me that I am doing the right thing? Okay, so okay, I guess we'll just never have anything working on my local environment ever again. Well, we're going to quit this and just try this again. Quit. And then we're gonna reopen it. And it really should not be giving me this many issues. It didn't before. Okay, well, it is like, you are going to freak out on me, I'm going to freak out on you as well. So, my cat, Megway, has decided that she does not want to be on my lap tonight. She wants to be next to my lap tonight. Why would we want to restore history? So I thought that we were going to fix this off screen and be like a cool kid that could tell you what was happening. But we are literally just going to turn the environment on and off again until it works. Why would you restore anything if it's broken? Okay. Okay. Both is code. Is this what's causing the issues? Is I have too many extensions? I mean, I don't always read the warnings of things, but it is annoying that something is not working the way it's supposed to. Command C, and then I just kicked my cat off my lap because I've been sitting here for long enough that my ankles are starting to get like pressure sores. So, artifacts, build info. Name is Sulci, and it's 8.17, right? So okay. Control Shift P. Command Shift P. And then Control Shift P. Um, um, that is super weird. I don't know. Fine, but it's not correct.
That we'll say contract, raffle. We can even make sure that we're not going crazy by doing a little yarn, hard hat compile, and compiled successfully. We want it to be able to enter the
But that other answer was the correct answer that you should. weird and also super weird.
Lottery. We want users to be able to enter it. So maybe we'll create a function called enter raffle. What else?
Okay. I don't agree. I think you should just do one function at a time. Do
What do we want to do? We want to be able to pick a random winner. So maybe we'll create a function called pick random winner. And boom.
function pick.
So let's comment out pick random winner for now, and let's just work on this enter raffle thing. In the past, we've created projects like FundMe where people can send Ether to our contracts or send whatever native blockchain token to our smart contracts using the message.value based off of some USD value. For this one, we're just gonna have the entrance fee instead be USD based. It's just gonna be that native asset. So for our enter raffle, we don't have to set a USD price. We can just set a minimum ETH price. So up at the top, let's pick our minimum price. So we'll do a UNT 256 entrance fee. And now some of our learnings from our last section should come in here.
Also, this is a fair refresher. UINT 256 entrance fee equals, I think there's a library that you can import or something.
We now know that this entrance fee is going to be a what? It's going to be a storage variable. So let's prepend.
So it's a storage variable so that it costs less to
Did with s underscore. Let's make it a private variable because we all.
someone at some point is going to rewatch this and point out that I can't spell.
Always want to set our visibility, but let's have the entrance fee be configurable. Well, let's create a constructor now, and we'll have this entrance fee be settable.
So yeah, the constructor is just like and the underscore just means that it comes from the outside.
In our constructor. So our constructor will take a uint 256 entrance fee s.
It's not TypeScript, Amy.
underscore entrance fee equals entrance fee. Well, if we're going to only set this one time, we might as well make this a constant or an immutable variable. So let's make this an immutable variable. So
I am not good at semicolons. What are you complaining about? UN 256, private, immutable.
so that we save some gas, we'll change this from S to I, and now we're
So, private, okay, so it's not storage, it's immutable. And then also this here.
we're saying UN256 private immutable I entrance fee equals entrance fee. Now we probably are going to want other users to see the entrance fee. So down below, we can create function get entrance fee.
Allow people to see the entrance function get does public go behind I think instead of semicolons, it is a second set of parentheses. It goes somewhere in there, okay?
And this will be a public view function, which will returns a UN2.
Public views returns with the in parentheses? Yeah. The lights turned off in my house.
And we'll just say return I entrance fee. Now we have a function that users can call to get the entrance fee, but we as developers can use this I entrance fee to know, this is an immutable variable. This is pretty cheap gas-wise for us to read from. In our enter raffle, we've done a ton of these before. All we need to do is we just need to require the message.value is greater than that I underscore entrance fee. But we've learned before about those error codes. So we could use require message.value, or we could do one of these custom errors, which is going to be a lot more gas efficient, because instead of storing this string, we're just going to store an error code in our smart contract. So let's do that instead. We'll say if the message.value is less than.
Okay. I remember doing this, I don't remember how we got around to it, so if message dot value is less than the I entrance fee. We're gonna go ahead and do things with this.
Then our I entrance fee. Then we're just going to revert the whole transaction with some error code. And we'll use our best practice naming raffle underscore underscore not enough ETH entered.
Underneath the pragma. So raffle underscore underscore not enough ETH or entrance fee. And then down here, and it's just revert. Maybe something like that.
We'll grab this error code and we'll have, if the user doesn't send enough value, we'll revert with not enough ETH entered.
With it being a function.
Now that we know they're calling enter raffle with enough value, we're probably going to want to keep track of all the users who actually enter our raffle. That way, not enough ETH entered. We'll grab.
Okay. So so on line 11,
not enough ETH entered.
and it has the parentheses there.
We'll grab this error code and we'll have, if the user doesn't send enough value, we'll revert with not enough ETH entered.
Also, set solidity compiler VS Code. Oh. This is much harder when yeah, that's what it was showing before. I'm gonna close this again. Gonna do this again. Okay. So we got it to compile. But I've gone back like 3 times to go see this, so we'll just go to show more, to the GitHub. I'm not being shy about this anymore. I want to get past the point where I was before. Oh, did I... No, it is defined outside of the... Does that go before or after pragma? Everything goes after the pragma. Quite okay with having the errors. Why are there two Solidity files? That's fine. Did he do the word?
Now that we know they're calling enter raffle with enough value, we're probably going to want to keep track of all the users who actually enter our raffle. That way, when we pick a winner, we know who's in the running. So let's create an array of players at the top. Error here. And then just to make this look even nicer.
Oh, see? He was wrong. I was just wondering why it wasn't working.
We'll do a little comment here, and we'll say state variables. And we'll combine both our storage and our not storage variables. Variables just in this state variables section. So we'll do address array.
Okay. Address array. Is this also private? It's not immutable though.
Players. Now players, of course, is going to have to be in storage because we're going to modify this.
So storage. Do you not say storage?
A lot. We're going to be adding and subtracting players all the time. So we're going to do S players. We'll make this private as well. And we're going to make this address payable player. Players. Because if one of these players wins, we're going to need to have to pay them. So we'll make this address payable private as players. And since we're going to make this private, and it's probably good that we know who's in the players array, we'll even do function get player. This will be a public view that returns an address of one of these players, and we'll just return
function get player public u returns return Okay, well that's not how you do it. Let's see how.
S players of index. We'll have this function take a U into the piece.
Okay, so get player u into 56. Does this make sense?
6 index as an input parameter. We know that players is going to be a storage variable, and we're going to add it to our enter raffle. Oh, and we definitely want our enter raffle to be public and to be payable.
Okay.
Since we're having people send message.value, and we want anyone to be able to enter our raffle. So it'll be public, it'll be payable, it'll be perfect. Now that we have our array and someone's entered the raffle, we'll do splayers.push message.sender. Now this
S
doesn't actually work because message.sender isn't a payable address, so we'll need to typecast it as a payable address.
Okay.
Just by wrapping it in payable. So now we have a way to keep track of all the players that are entering our raffle.
Introduction.
Now, one of the
to
concepts
events.
that we haven't gone over yet is actually going to...
I think this is where we stopped last time. Oh my gosh, we are so close to being 14 hours into a 32-hour course. It is only midnight. We have 6 more minutes. We will get through this. This is so much harder in the dark, by the way. I can't see my keyboard. There's no backlit to my keyboard. I am currently being silly. I am going to turn on my light. Right switch? Nope. Okay. And then depending on how I look, I will finish messing around with my hair. Fine. I have a thing and it's stuck and it's fine.
Be events. And events are really important to our smart contracts. Whenever we update a dynamic object like an array or a mapping, we always want to emit an event. When we get to lesson 10, and then especially lesson 15 with the Next.js NFT marketplace, these events will make a ton of sense, especially for front-end developers. So right now, events might be a little bit of a weird thing for you as we explain it, but as we continue on, they'll start to make more and more sense. So we're gonna start adding events to our smart contracts whenever we update one of these dynamically sized data structures. And to learn more about events and how to use them, we're gonna watch another video that explains all about events. You can absolutely follow along with this video as a side project, but let's learn all about events. Now, if you've worked with Solidity, you've probably seen these things called events before. Or maybe you haven't seen something like events, but you've always wondered how Chainlink or the Graph or some of these other off-chain protocols work under the hood. And in this video, we're gonna learn about logging and events in Solidity, viewing those events on Etherscan, and then working with them in Hardhat. Now, it's the Ethereum Virtual Machine, or EVM, that makes a lot of these blockchains tick, like Ethereum. And the EVM has this functionality called a logging functionality. When things happen on a blockchain, the EVM writes these things to a specific data structure called its log. We can actually read these logs from our blockchain nodes that we run. In fact, if you run a node or you connect to a node, you can make a getLogs call to get the logs. Now, inside these logs is an important piece of logging called events. And this is the main piece that we're gonna be talking about today. Events allow you to print information to this logging structure in a way that's more gas efficient than actually saving it to something like a storage variable. These events and logs live in this special data structure that isn't accessible to smart contracts. That's why it's cheaper, because smart contracts can't access them. So that's the trade-off here. We can still print some information that's important to us without having to save it in a storage variable, which is going to take up much more gas. Each one of these events is tied to the smart contract or account address that emitted this event in these transactions. Listening for these events is incredibly helpful. Let's say, for example, you want to do something every time somebody calls a transfer function. Instead of always reading all the variables and looking for some to flip and switch, all you have to do is say, listen for event. So a transaction happened, an event is emitted, and we can listen for these events. This is how a lot of off-chain infrastructure works. When you're on a website and that website reloads when a transaction completes, it actually was listening for that transaction to finish, listening for that event to be emitted so that it could reload or it could do something else. It's incredibly important for front ends. It's also incredibly important for things like Chainlink and the Graph. In the Chainlink network, a Chainlink node is actually listening for request data events for it to get a random number, make an API call, or etc. Sometimes there are way too many events, and you need to index them in a way that makes sense so that you can query all these events that happen at a later date. The Graph listens for these events and stores them in the Graph so that they're easy to query later on. So events are incredibly powerful and they have a wide range of uses. They're also good for testing and some other stuff, but you get the picture. They're really sick. Now that we know what events are, let's look at what they look like, how we can use them, and how we might use them in our smart contract development suite. Now, here's what an event is going to look like. We have an event here called stored number. So we have basically a new type of event called stored number. We're saying, hey, Solidity, hey, smart contract, we have this new event thing. We're going to be emitting
things of typed stored number in the future. When we emit this event, it's going to have these 4 parameters. It's going to have a uint256 for called old number, a uint256 called new number, a uint256 called added number, and an address called sender. Now, for the astute people here, you might have noticed that there is another keyword in here, the indexed keyword, and this is a really important keyword. When we emit one of these events, there are 2 kinds of parameters. There are the indexed parameters and the non-indexed parameters. You can have up to 3 indexed parameters, and they're also known as topics. So if you see a topic, you know that that's going to be an indexed parameter. Indexed parameters are parameters that are much easier to search for and much easier to query than the non-indexed parameters. In fact, way back in that fgetlogs function, it even has a parameter allowing us to search for specific topics. So it's much more searchable than the non-indexed ones. The non-indexed ones are harder to search because they get ABI encoded, and you have to know the ABI in order to decode them. Now, this just told our smart contract that there is a new type of stored number, a new kind of event here. We need to actually emit that event in order to store that data into the logging data structure of the EVM. To do that, we need to do something that looks like this. This is what it looks like when we emit an event. It looks very similar to calling a function. So you call emit, and then the name of the event, and then you add all the parameters in there that you like. Here's the full example of a smart contract that has an event, and is going to be the example that we walk through in Hardhat. Now, in this smart contract, whenever anybody calls the store function, we're going to emit this event. Here's an example of a transaction where we called the store function with a value of 1. Let's look into the logs to see what this event actually is going to look like.
Okay. As you can probably see, I'm watching this, but my hair is stuck in this contraption that I used to do a fancy bun today. And I'm a little distracted by the fact that I'm gonna have to cut my hair out of this. There might not be any saving my hair. So, I think that is enough of Solidity tonight. We will rewatch events tomorrow. This is important. I think last time we did this, I was like, no, I'm too tired to understand what's going on with events. We'll rewatch this. But seriously, I need to get my hair out of this contraption, and I need to not be on film while we're doing it. And then, it's gonna be the 3rd time I'm watching about these dumb events, but from what I understand, what's going on right now, in as much as I'm paying attention to anything that's not my hair being trapped, there's the index, and you can have 3 topics, like they're called topics, and everything that is not indexed is a bitch to search for, because you have to know the ABI of it. It's kind of like a database where you can have, a database, you don't have a limit to how many topics or indexes you can have, but you can name alias indexes, and they're, you can have like more than one column be in a aliased index. And the way indexing works in databases is that if it's not indexed, it's kind of terrible to search for it. But if it is indexed, it is relatively quick. So I stand by my instinct to just use Web3 as an expensive database.
An event is going to be broken down like so. The address of the contract or account the event is emitted from. The topics are the index parameters of the event data. This is the ABI encoded non-index parameters of the event. What does this mean? This means that we took those parameters that were non-indexed, we matched them together with their ABI, or application binary interface, pumped them through an encoding algorithm, and boom, this is what we got. If you have the ABI, they're very easy to decode. If you don't have the ABI, they are very hard to decode. These non-indexed parameters cost less gas to pump into the logs. Now, in this particular contract, since we have verified the code, we verified the contract, Etherscan knows what the ABI is, and we can view this in dec or decoded mode. Hex mode is obviously the non-decoded mode, or in its raw hex or hexadecimal or encoded mode. You can read more about the layout of these events in the Solidity docs.
Now, so that's the basic introduction of events. And for those of you who want to watch the rest of that video and who want to actually practice using events yourself, there's a link to these videos and the code repository associated with that video if you want to play with it and if you want to learn more. So feel free to refer back to the full Blockchain Solidity course JS if you want to go deeper into events. Now that we're back and we've learned a little bit more about events, let's add some events to this contract. Remember, these events get emitted to a data storage outside of this smart contract. Let's create an event called raffle enter. A good syntax for naming events, name events with the function name reversed. So for enter raffle, we're gonna say raffle entered. So up at the top, below our state variables, but above our constructor, we'll create a new section called events, and we'll create our first event. So we'll do event, raffle enter, and we'll just have this raffle enter take one index parameter. It'll be an address indexed player. So in our
before the constructor, it's kind of painful. Not prepared for this. The function. So instead of enter raffle, it is raffle and this is my cat telling me it is definitely time for me to go to bed. Is it called a function? It's an event, Amy. And it's taking in address indexed player. And it's not a function, so you don't need the curly braces. Do need a semicolon though.
enter raffle, we're gonna say emit raffle enter, and we're just gonna pass it message.sender. I'm gonna remove
Kids, don't do this at home. What is my hair doing? So, there's beads at the end of this wire thing that basically I put my hair in the middle and I twisted it up. And the only problem with twisting things up is when it doesn't twist back out like it's supposed to. And I just want the majority of my hair back. Like, could we just get my hair out? Okay, thanks. Just open up the jaws of death and get the majority of my hair back. That would be really great. Thank you. I don't need to be twisting all of my hair through all of this. I've used a different type of this before and with no issues. It was just this time I was in a hurry and did it in such a way that now my hair is forever trapped. So we will get this out while we are working on the contract. Should we not have like truffle or ganache or something compile this and like check it out?
Move these comments for now, but feel free to leave them in as you code along. Now, in this part of my raffle coding or my lottery coding process, I probably would start already writing some tests and already writing some deploy scripts. The reason that we do this is it's good to test our functionality as we progress.
Hey.
And often,
While we're doing ChatGPT, we can say, please write a test for the following solidity function. I definitely didn't do any. Did something happen? Okay. The Pragma version is dumb. It tests the entrance fee. It does not test the emit or the amount in the array, but do you really need to test that? That is a like basic solidity thing. So sure. I guess. I don't even remember where tests go, honestly. Is this written in jest? This looks like could be. Please write a test for this solidity contract. Okay, it didn't read the pragma. It has truffle. Okay. I'm almost out of my hair too.
Times when I'm writing smart contracts, I'm constantly flipping back and forth between my deploy scripts, my contracts, and my tests to make sure everything is doing exactly what I want it to do. For the purpose of this course, and just to make it easy for you to learn and follow along, we're not going to do that, and we're just going to keep writing their smart contract almost to complete and then move to our deploy scripts and tests. So in its minimalistic sense, we essentially have a way for people to enter our raffle. Now we need a way to pick the random winner, and this is where we're going to need Chainlink VRF and Chainlink Keepers. So let's again watch some sub-lessons about learning about Chainlink VRF and learning about Chainlink Keepers. We've made some videos about these before, so we're just going to play these videos so you can learn about how Chainlink VRF version 2 works and also how Chainlink Keepers works. Then we're going to come back and
Note, I know way more than I want to know about VRFs because Optimism does not have them. And I was not in a position to be able to help my teammate get around this big technical hurdle. And it is a big deal to not have a VRF available in a blockchain. It turns out that randomization is fun until you don't have it. But yeah, so we're using Ethereum. It's available in Ethereum. It's an oracle. What's there not to love? Oh my god, my hair's holding on for dear life.
we're going to add them into our contracts here. If you're already familiar and you already played with them, feel free to skip those sections and we'll just get to building them here.
Hi, my name is Stephen Fluin, and today we're going to be taking a look at Chainlink's VRF version 2. VRF version 2 has a few different mental models that we should be aware of, and I want to show you what it feels like to be using it. The big important thing to know about VRF version 2 is that instead of the VRF 1 model where you'd be funding your contract with Link, instead you're going to be funding a subscription, which is basically an account that allows you to fund and maintain balance for multiple consumer contracts. Let's dive into the docs and see what using VRF v2 looks and feels like. In order to show this off a little bit, I'm going to dive right into the get a random number guide in the Chainlink documentation. And so it's going to go through a few of the requirements of some of the technology we're going to use today. And the first thing it's going to ask us to do is to make sure that we are on the Rinkeby testnet. So let's go ahead and jump over to Rinkeby, make sure my MetaMask is unlocked here. And now that I'm on Rinkeby, great. I should be able to use the VRF version 2 testnet. Now we're going to jump over to Subscription Manager. And the Subscription Manager is where we're going to manage our subscription account. Basically, this is the place that you put the funds in order to be able to use it across a bunch of different chains. So we're going to go ahead and connect our wallet here in order to use the subscription app. And then we're going to go ahead and create a new subscription. So we'll just use my address as the subscription address here. I'll approve the creation. And as soon as that transaction is confirmed, our subscription should be created. All right, now we have a subscription. Basically, this is the account where we're going to fund it, and then we can use that account for all of our randomness requests. So I'm going to go ahead and just put in 10 link here. You can put in however much you want. The price in link of every random number you request is going to be based on the current gas rates on a given chain, as well as the gas lane that you've chosen. All right, our funds have been added. Let's go ahead and add a consumer contract. So it's asking us for a consumer address. We don't actually have a consumer address yet. So let's go ahead and jump over to the documentation and create a contract that is going to request a number. So if you scroll down, you're going to see this VRF-v2 consumer.sol contract that we can open in Remix. Let's just jump right there. We're going to notice a few different things in this contract. At the top, we've got some imports. So now you've got VRF consumer base version 2. We've got an interface for the VRF coordinator, and then also a reference to the link token interface. So all of those are specified for you on the Rinkeby network here in the example code, and then you can refer to the documentation for whatever chain you're going to be deploying to. And then you're going to see a few new options here. So the key hash option is the way that you specify that gas lane that was described in the documentation. So depending on the key hash you choose for the given chain you're on, the gas limit will be set differently for your random number request. So for example, on Ethereum mainnet, we have a 200 GUI key hash, a 500 GUI key hash, and a 1000 GUI key hash. You can also see in our contract here that we have a callback gas limit that you're in charge of. So depending on how much gas you're willing to spend in the fulfill random number, you should set this value appropriately. Next up is request confirmations. So this was something in VRF-v1 that you could not control, but here now, depending on the chain you're on, depending on the request and the type, nature of the request you want to make, you can actually change this number. And then one of the most important and useful features that gives you a lot more flexibility and control of your VRF is you can actually specify the number of random numbers you want. So you specify the num words, and then that will specify how many random UNT256s you get back from the network. All right, here in the constructor, we're going to see a address for the coordinator, an address for the link token, and then you'll see that the subscription ID is going to be created as we deploy the contract. And so I'm going to go ahead and get that. So if you remember when we created the subscription, after we funded it, we see the subscription ID. And now when I deploy this, I'm going to use that subscription ID. And we've got two methods that should look very familiar. We've got fulfill randomness method that takes in the randomness. This is going to be fulfilled by the VRF Oracle, as well as you've got request random words, which is how we're actually going to initiate that request to the Oracle. So I think we're actually already ready to go ahead and deploy this. So let's jump to the deploy screen here and select the right contract, which in our case is VRF-v2 consumer. And I'm going to make sure that I am on injected Web3 so that we can actually deploy to the Rinkeby network. And I'm going to paste in the subscription ID here, and I'm going to deploy. Let's go ahead and pay for that transaction. And as soon as that is confirmed by the network, we'll show up here, and we'll be able to copy this address and then add that as a consumer and authorize this contract to use my subscription account. So let's go ahead and authorize this with another MetaMask transaction. All right, we can now view our subscription. We can see how much link we funded it with, and we can see our consumer contract. So now by doing this, we've authorized our consumer contract to make requests for randomness. So let's go ahead and make a request for randomness here. So we're going to go back to our contract that we deployed here, and we're just going to use the Remix interface here to keep things simple. And I'm going to request some randomness. So obviously this is going to use all of the configuration that I specified in my contract, just kind of hard-coded here. So we're going to get 2 words of randomness here. So we're going to hit request randomness, confirm the Rinkeby transaction. And then as soon as that transaction comes back, we should notice that we actually have a request. And then what we'll be doing is we'll be waiting for the Oracle to call fulfill random words on our contract. And then we'll be storing all of those random words in this sRandomWords storage variable. Let's go ahead and check to see if our random numbers come back from the Oracle. So I'll go in here into random words and let's request the 0th item of the array. Looks like we've got a random number there. And because we requested 2 random numbers, we should also have an item in index 1. All right, we've got our randomness there. And if we go back to the subscription manager app, you're gonna see that there's actually an event history item here. We'll see that we spent about 0.33 link to get those 2 random numbers. We've just taken a journey to see what it looks like and feels like to use VRF version 2.
Now that we've learned a little bit more about Chainlink VRF, hope that you took some time to go to docs.chain.link and play around with it a little bit so that you understand what's really going on. We're going to use this sample contract in here.
He hopes that we took the time. I took the time to untrap my hair. Although he does have a point where I probably should actually just go into Chainlink, make sure I understand what's going on. The only question I have here is when it says like get random words. We're getting a hash back, right? Or is it a number? Like, is it a word or a number? I think it's a hash. So it's neither a word nor a number.
To create our function that's going to pick our random winner. This is an on-chain contract that coordinates with a verifiably random Chainlink node to give us a random number. You could look at the code directly on chain, or you can come right to the Chainlink GitHub and look at all the code for how this is actually happening provably and randomly. And we'll have a link to this in the GitHub repo associated with this course. So we're going to create our function here called pick random winner. This function is going to be called by the Chainlink Keepers network so that this can automatically run without us having to interact with it. And actually, while we're updating this, I want to add some stars here saying view/pure functions. Now, our pick random winner function, we're actually not going to make public, we're going to make external. External functions are a little bit cheaper than public functions.
Okay. External.
Because Solidity knows that our own contract can't call this. We're actually going to change the name of this function as well very soon, but we'll get to that in a little bit. So in order for us to pick a random winner, we actually have to do 2 things. We first have to request the random number, and then once we get it, do something with it. So Chainlink VRF is a 2-transaction process, and this is actually intentional. Having random numbers in 2 transactions is actually also much better than having it in 1. If it's just 1 transaction, then people could just brute force try simulating calling this transaction, and we'll learn how to simulate calls soon. Simulate calling these transactions to see what they can manipulate to make sure that they are the winner. We want to make sure that this is absolutely fair and nobody can manipulate our smart contract into having them be the winner of the lottery. This function is actually going to request it, and then in a second function, the random number is going to be returned, and in the transaction that we actually get the random number from the Chainlink network, that's when we're going to actually send the money to the winner. And if we go to the Chainlink documentation, the function that the Chainlink node calls is this function called fulfill random words. This is going to be the requesting one, which we could even change this to request random winner to make it more clear, and then we'll make a function fulfill random words. And this is going to be an internal override, which we'll explain in a little bit. Now, fulfill
First of all, it's time for me to go to bed. Second of all, that's not even the correct function. The external one is, function request random external and then there's a second one called function fulfill random words internal override.
Fulfill random words basically means we're fulfilling random numbers. The word comes from a computer science terminology, but you can basically just think of this as fulfill random numbers because we can get multiple random numbers. Now, in order to make our raffle contract VRFable, we have to import the Chainlink code. We can go back to the documentation and we're just going to grab this bottom line and we'll grab the top line in a second.
Oh yeah, no, I'm getting up there and being tired. I think I'm gonna go to bed. See, I have my thing wrapped around my wrist, and then I played with my hair, and it got stuck again. It's fine. You know what's not fine, though? The fact that I'm still awake. So, I'm proud of myself for getting 14 hours, 12 minutes into this course. And everything is downhill from here. Getting kind of close to being the halfway point. I feel halfway done. How long is the lottery? The lottery is 3 hours long. But when we're done with the lottery, we'll be halfway done with the course, so there's that. Lesson 10's gonna be fun. I really should just get through this stupid course. I should probably stop calling it a stupid course. Anyway, we're at the end of the night where I'm not doing anything except for rehashing things. So have a good night. I will see you later. Good night.